Okay, so yes, I would multiply both sides of this equation by 4 to get rid of those fractions. So that's what I'm going to do. I'm going to multiply both sides by 4. And then I'm going to go through and multiply every term by 4 now. So half of 4 is 2. So this will be 2x. And then plus 8. 4 times 1/4 x is just 1x. But we don't have to put the 1 there. We can just put an x. We always assume that if there's just a variable, there's only one of them. And then 4 times -6 is -24. So we took something that looks pretty complex, and now that's pretty basic, right? Not too bad. So I'm going to go ahead and both sides are already simplified. There's no more grouping. There's no like terms. So I'm going to move my variables over. I'm going to just subtract an x from both sides to get rid of that right there. And 2x minus x is just an x. Bring down the plus 8 is equal to -24. And last step, I'm going to subtract 8 from both sides. We'll get that x is equal to -32. Now, usually I would say, especially on a test, it's so good to check your answers, but you don't want to spend all your time checking answers. So I would always go through, I would solve everything first, and then if you have time, go back and check all of your answers. And always save your fractions and decimals for last, because those ones are going to take the most time. But when I'm looking at this, if I were to plug it in, the numbers actually are pretty clean. So I'm going to check it. Because the truth is, it is always a good idea to check your answer if it is possible. So I'm going to plug in -32 here for each of these. Okay. Well, half of -32 is -16. A fourth of -32 is -8. Yeah, Jordan.
If, say there was like parentheses around the x and the 2,
Mm-hmm.
would you still multiply 4 by those things?
No, only the number on the outside. Yes, and I'm going to do an example like that next. Yep. All right, and then 16 plus 2 is -14. -8 minus 6 is -14. So we know that our solution of -32 is correct. So that only took me a short time. So if it's going to only take you a short time to check it, you should. Now that one was pretty straightforward. It's not much different than what we did when we were solving two-step equations. So let's take a look at what happens when we have some grouping. Just like the decimals that we talked about on Friday, when you have grouping there, you need to handle it differently. Okay. First of all, what would I multiply both sides by to get rid of those fractions? 5. Yes, I would. So I'm going to multiply both sides by 5. Now, this is not going to drum to the usual beat, so let's go through it real quick. I'm going to multiply both sides by 5. Now, this side is pretty straightforward. You're just going to distribute like regular. So this is 15x, and then this will become -4. But there was grouping here. And remember, when you have grouping, you only multiply the number on the outside of the parentheses by 5. Okay? And then once you distribute after that, you basically will be distributing the 5 eventually. So 5 times 2 is 10. Okay. So So usually, once you do that first step, all of your fractions clear and you move on. But in this problem, you can see that you still have a 1/5. But as soon as we distribute, that 1/5 is going to go away. So let's distribute and see what happens. This side is already reduced, so we can leave this side alone. And then I'm going to distribute the 10. So this will be 10x. And then 10 times 1/5 is going to be 2. And now all your fractions are gone. So even though it didn't happen all in one step, we were able to clear all those fractions and get a much nicer equation to solve. Do you have a question, Heidi? No? Okay. All right, let's continue on now with our normal things. So we've gotten rid of our grouping. In this case, there's no like terms, so we don't have to do that. But so now we can just move all of our variables to one side. So I'm going to subtract 10x from both sides. Could you subtract 15x? Absolutely. You'll get the same answer. So this will be 5x minus 4 is equal to 2. Add 4 to both sides. You'll get that 5x is equal to 6. Divide both sides by 5. And you get that x is equal to 6/5. Or because it's not a repeating decimal when you divide, you can write it as 1.2. Either one is fine. Now, this one would be kind of tricky to go in and check your answers on. So I would not spend time on that on a test unless you definitely had some extra time to kill. Yes, Irvin?
Made it to that the answer checker accepts both improper fractions and decimals, right?
Yes, unless the decimals are repeating, then you need to leave it as a fraction.
Okay.
Yeah, so if the decimal's a terminating decimal, it will be there. If it's not a terminating decimal, then you'll need to leave it in fractional form. Okay, and make sure you reduce those fractions. So I'm going to have you try one that has some grouping in it, just so that we can make sure we're good, and I'll walk around and help you guys. All right, guys, try that. Oh, he's back. it. All right, let's take a look at what happened here. I'm just going to quickly fill this in for the sake of my notes. So this is going to become, these cancel out, and you get 3 times x plus 4 equals 4 times x minus 1. So clearly you guys did a good job of making sure that you multiplied that right. Then we distribute. Then we are going to get all of our variables to one side. And we get 12 is equal to x minus 4. Add 4. And we get that 16 is equal to x. So yeah, great job, you guys. Great job. All right, let's go ahead and if you have room, you can continue on, but I'm out of room, and this problem's going to take quite a few lines. I want to show you one more situation for fractions, and then I'll let you guys get your work started, okay? Okay. So sometimes you're going to have problems that look like this. And it's important to remember that all the stuff on the top of the fraction is considered grouped. So in this case, what will we multiply both sides by to get rid of our fractions? 12. Okay? So because all of this is grouped, we are only going to deal with the 12s. Okay, 12 divided by 12 is 1. It goes away. And then all that's left is the stuff that was on the top of your fraction. Does that make sense? Yes? Yes, I hope so. Okay. So this is 8 times 4n plus 12 is equal to 144. Yes?
Are we supposed to do 12 times 8?
I could do 12 times 8, but then I would divide by 12 again, and it would undo what I did. Because 12 times 8 is 96. 96 divided by 12 is just 8. You got it? Okay. All right, so at this point, if we follow the steps that we've been doing, we always distribute, combine like terms, move our variables over, all that jazz. So here I would distribute. Another strategy that we learned when we were solving two-step equations is that you can actually divide both sides by 8 here as well to get rid of that. But because I feel like you guys are more comfortable with just distributing it, I'm going to do it that way. So this will become 32n plus 96 is equal to 144. I'm going to subtract 96 from both sides. We get 32n is equal to 48. Divide both sides by 32. Okay, at this point you have some options. You can just reduce it and leave it as a fraction, 3/2. Or you could do 1.5, or you could do 1.5. Since this is a decimal that terminates, like the decimal ends, it's exact, you can enter that as a decimal. Okay. Any questions for me? Was that as bad as you all thought it was going to be?
Yeah.
Yes, no. The last class was like, oh, that was way better than I thought it was going to be. I'm going to put your table of contents up here. Hey guys, I'm going to be walking around. Let me know if you have questions. You can get started.